look at the left side of this warm-up today, they're in the directions coming right out, and they're telling you, hey, these two functions, function f and function g, are inverses. You're given that fun fact. Today, we are starting off by just exploring what that relationship between two functions might look like. So what they want us to do in this particular warm-up, on the left side, for instance, we see f of x equals 2x to the third plus 1. They just want us to list out the steps you would carry out if they gave you a value for x. So for instance, if they gave me a value for x on this left side, based on the order of operations, I would have to cube that value of x first. You follow? Because there has to be exponents first. So the first thing I would have to do is cube x, whatever that number is that they gave me. What would you have to do next? Yeah, so step 2 would require us multiplying by, oh, that's kind of confusing. Huh? I'll just write the word. Let's multiply by 2. And the last step, what would I have to do then to evaluate this function? Emily, add 1. Okay, take a quick moment right now. I want you to do the same thing for function g. If somebody gave you a value for x, what would you have to do first? What would you have to do second? What would you have to do third? But, so what do you do first? They give you a value of x. What do you do? Go ahead, Kristen. You would subtract 1 first. That's very good. Then what do you do? Alec? You would. And lastly? Yeah, you would cube root it. Okay, now we're ready to answer question number 1. Real general. What do you notice about the two sides? And no, you can't say they're inverses of each other. That's given. What I'm looking for is what kind of makes them inverses. So what do you notice about the two sides? Go ahead, Jared. So it's reverse order is what I hear you say. So where number 1 was cube x on the left side, number 3 was cube root. And then number 2's kind of line up. We have multiply by 2 and then divide by 2. Right. And then number 3 on the left says add 1, but that matches with number 1. And then I heard you say a word before you started all that. They're opposites. Very good. So not only are they reverse order, but they're opposites with regard to how they work out or evaluate values for x. Do you see that? Pretty neat. So these equations would actually undo each other, right? You have lots of things that undo each other, and you just got to see, 3 right here. There's actually another interesting relationship that sort of comes out of this, and that's within the context of composite functions. So I had to teach you yesterday's lesson and the day before in order to help you define what inverses are. So I need you to take a moment now. I want you to find f of g of 3 and g of f of 3. And then there is a question sort of buried down below there. After you evaluate f of g of 3 and g of f of 3, I want you to just talk about your observations from number 2. So go ahead and let you do. Okay, what did you notice? Yeah, okay, the first thing you said was the more important of the two things. When you evaluated f of g of 3, you got 3. When you evaluated g of f of 3, you got 3. What's important about this isn't that you inputted 3 into both. It's that the answers were the same. Honestly, Kristen, and hey, the rest of my wonderful period 9 class, I could have said find f of g of 2 and g of f of 2, or f of g of 1 and g of f of 1. And you would have gotten the exact same output for both of those functions because you were doing some very similar steps. So in the space below, what did Kristen notice? The outputs were the same. So they were the same. This is actually really important. I used a pronoun. I don't really like that. The functions evaluated, say that. To be both 3. Say that. Okay. I know I pick on pronouns. I should be more cautious about it myself, right? So the outputs were the same. Okay. We have some vocabulary. I'll go ahead and let you copy those words down. They both have the word inverse in them, but they are 2 different definitions. An inverse relation is described as a relationship, something between x and y, that interchanges the input and output values for an original relation. I really wish, and I think I did this year, I know I always said in years past, like, I wish I could just change the title of this in the book to switching x and y. And I think this year I actually went back and finally did it. I put in the title, we're switching x and y. And honestly, if there was one fun fact I could make you leave the room with today, that would be it. If you see the word inverses, you need to think about switching x and y. Flat out. And everything associated with them. So if it's a word problem, you'd have to switch the values of your control and your dependent variable. If it's a graph, you have to interchange values for your domain and your range. In a function, we're going to swap out x for y and solve for y in just a moment. An inverse function is a unique type of inverse relation. It's an inverse relation that happens to be a function. It actually occurs, it's the case where your original relation and then that inverse are both functions. What's a function? Function, what is that? Do you remember? You had to memorize the definition back in chapter 2, so like September, long time ago. Anybody tell me anything about a function that they remember? Maybe we did a special test. Danielle. Good girl. Verbatim. Nicely done. Yeah, for every x value, there needs to be exactly one y value. That's pretty good. Did you just shock yourself? You're like, I read. No, you're good. Oh, okay. Alec, you were going to say something too, I think. Okay. You're on the right track? There's a test for a function. Do you remember what it was, Anthony? Vertical line test. Can anybody run me through that real quick? We're about to take a midterm. This is helpful. Vertical line test. What's that do? What's that for? Oh, Kristen's like, no. Go ahead, Anthony. Then it's a what? Yeah, if it hits more than once, it's not a function, right? That's how that test officially works. Okay, today we get, oh yes, the horizontal line test, but that'll be in the last like couple minutes of class today, so that's later. As promised, you're getting 3 skills today, 3. You're gonna learn how to write an inverse function. You're gonna learn how to verify 2 functions are inverses, and oh yeah, last but not least, you're gonna learn how to graph an inverse function. So 3 skills today. It's a busy day for you guys. Busy. So let's start. In example 1, it says find an inverse relation. These are pretty straightforward problems, I think, in my opinion. Step 1, we do switch x and y, or interchange x and y. So you look at your original function up here. There it is. See it? Y equals 3x minus 5. We're going to interchange our x and our y. So instead of writing y equals 3x minus 5, we write that as x equals 3y minus 5. In step 2, you solve this resulting equation for y. You got to get the y by itself. So I'll bring down my equation from step 1, and my hope is to isolate that y value. in order to isolate the y value here, I would just need to basically add 5 to both sides. And then on the right side, you get x plus 5. Oops, I wrote x plus 3. Hold up. So on the left side, that balances to be x plus 5, and that's equal to 3y. I'm almost done. I'm going to come back up here for a second. So I have x plus 5 equals 3y. I now need to get that y still by itself, so I'm going to divide both sides of that function by 3. So right now I have y equals x plus 5 all over 3. I'm going to do two things. I'm almost done. Almost done. The last thing I have to do is kind of cosmetic in nature, in my opinion. First things first, x plus 5 over 3. Could you look at that and tell me right away what shape that graph makes? It's completely normal if you say no. No, you can't. Okay, what if I rewrote this by just taking this 3 and dividing it into both things so that it is now 1/3 x plus 5 over 3. Would you know what shape that makes? A line. Very good. Yeah, that's y equals mx plus b. So I usually say take it one step further so that, ultimately a big idea in this class is you're supposed to start being able to look at an equation and see the graph in your head. Like that's what a big goal in this class is. So if you look at it like this first way, you're like, well, I don't know what that shape is. But if you look at it, you're like, if it's written in this second fashion, this 1/3 x plus 5/3, if you look at it that way, you're like, oh, that's mx plus b. I know what that is. So I encourage you to write it in this manner. I also think the back of the book, when you go to check your work tonight, it writes it like that. Danielle. You could do x over 3. I always think that in front of this x, there's a 1 hanging out anyway, So that's where I got the 1/3. But would you notice x over 3 as being linear in nature? So that's why I wrote it in a different way. Make sense? Okay. Alec? Probably a good idea, yeah, I would say. Remember, graphing is a part of our lesson too, so yeah. Eyes on the prize, it's probably good that you can recognize that's a line. So f inverse of x would be the last transformation. It's kind of not the best notation to say, hey, this is y over here. Y is 3x minus 5, and then, oh yeah, at the very end of my problem, y is also this. Like, that's not really good. So we actually swap out, at the very end of our problem, we swap out this last y right here for f inverse of x when that inverse is a function. So you're probably saying, Mrs. Lucas, could you say that phrase again? I don't know what that is. This right here, in words, is said f inverse of x. So that little -1 right there, it's not like we say, hey, it's f to the -1st of x. We actually read that as f inverse of x. So you'll see it in a couple of places. Questions about that? So that was skill number 1, done. You now know how to find an inverse function when you're given a function. So you switch your x and your y, you solve for y, and then you make those last couple of cosmetic changes at the very end. Okay. The next skill you get from me is the skill of verifying inverses. This is proving that two functions are indeed inverses of one another. And here's the test or the proof that you have to do. You're going to let f of g of x, you're going to evaluate that composite function, and it should give you x. And then if you work out g of f of x, and you get x there as well, it's then that we could say those two functions are inverses of each other. So you see why I had to teach you composite functions, because it's embedded in inverses. And then here's that thing again. That little f to the -1st is read as f inverse. Example 2 should look familiar to you. Does it? We just did it, right? We know based on what we did in the previous part of the problem, that if I find the inverse of f of x equals 3x minus 5, I will get f inverse x on the right. This process is a little different because we're proving, that's a different scale, we're proving these two things are indeed inverses of one another. And for the sake of this particular example, do you see how this is called f inverse of x? Well, I'm going to write two composite functions. One's f of g of x, and one's g of f of x. So I need a function g, right? I can't do f of g of x if there's no g. So I'm just going to call my inverse function, function g. And then I'm going to go ahead and find two things. So this is probably something you would probably be even able to take care of on your own at this point. I could do f of g of x, or I'm going to do f of g of x. And then I'm going to do g of f of x. What's nice about these problems is that the answer is already determined for you. I have to get x both times, or else I didn't, this example, these two things aren't inverses of each other. So I always work from the inside out. I'm going to replace g of x with what it's equal to. G of x in this problem is 1/3 x plus 5/3. And then this is telling me I need to substitute that in to function f wherever I see an x. So it was 3x minus 5, so it's 3 blank minus 5. And then where that x was, I need to substitute in 1/3 x plus 5/3. And then I distribute the 3 in. 1/3 of 3 is 1. 5/3 of 3 is 5. My 5's undo each other, and I get x. So that left one works out. Are there questions about that? Now I got to do it again. I have to do g of f of x. So I'm going to go ahead and take my f of x. I always work from the inside out. F of x in this problem is 3x minus 5. And then I'm going to go ahead and take function g and plug that in. So plug 3x minus 5 into function g. Here's how that looks. Function g was 1/3 x plus 5/3. So I'm now going to do 1/3 blank plus 5/3. And then what goes in that blank right there? In for the x, 3x minus 5 goes in. And then 1/3 of 3 is 1. So 1/3 of 3x is x. And then 1/3 times -5 is -5/3 plus 5/3. And look at that, I have additive inverses there on the right. -5/3 and +5/3, those would go away. And we get x. Woohoo! Because both of these things worked out to be x, it's official. Those two functions are inverses of one another. That's the verification step. So that was objective 2. So first thing you learned today was how to write an inverse function, right? You just swap out the x and the y, solve for y, and then insert your f inverse of x. To verify functions, you have to do f of g of x equals x and g of f of x equals x. And then lastly, that's a little bit of extra practice there, we're going to graph inverses. And remember, I changed the title of today's lesson, right? I said it's all about switching x and y when we do inverses. So what do I need in order to graph inverses? Well, I need some x's and y's. And what you're going to see here in this last example is they ask me to find the inverse of f of x equals x squared when x is greater than or equal to 0. And then in this case, we're going to practice graphing f and f inverse. So I'm going to graph f of x. And I'm going to do that by constructing a t-chart. Remember, they're restricting the domain for this function. Do you see that x is greater than or equal to 0? That's not there for decoration. Good people that are good at math are going to notice that detail there. You have to use this. That's not there for fun. That's information you need. They want our first input to be 0. And then I can pick numbers bigger than that. So if I square 0, I get 0. If I square 1, I get 1. If I square 2, I get 4. If I square 3, I get 9. So this gives us a real quick little graph here. 0, 0, 1, 1, 2, 4. And I get half of a parabola. To get the t-chart for the inverse, super duper easy. If you want to get the t-chart for the inverse, remember the title of today's lesson is just all about switching x and y. So all you're going to do is interchange the columns of your t-chart. That's it. Well, it doesn't look like much when you do the first couple points, because if you swap out 0, 0, you still get 0, 0. And if you swap out 1, 1, you still get 1, 1. But if you swap out 2, 4, you get 4, 2. And then if you swap out 3, 9, you get 9, 3. So check it out. Half of a sideways parabola. Anybody care to guess what function I just plotted? It's going to be one of our parent functions starting tomorrow. I plotted the inverse of the squaring function. Keep in mind our warm-up, we had a cube and a cube root. What function did I just graph? Kristen? The square root function. Very good. So that's one of the graphs that we're going to explore a little bit more tomorrow. So we get this graph for f inverse right there, and then the graph of f is up here. What you should come to notice is that ultimately inverses are always just reflections over the line y equals x. They're mirror images of each other. And that's why we end up swapping out the columns in our t-chart. And one last test for you. It's this test for inverse functions, right? I referenced it earlier. Anthony was nice enough to talk to me about the vertical line test today. We also have the horizontal line test for inverses. Basically, the inverse of a function f is also a function if and only if no horizontal line intersects the graph of f at more than 1 point. So check it out. We have a horizontal line in that first one drawn through a function. Do you see how it only hits in one spot? Just one spot. That means the inverse is a function. More than one spot, it's not a function. And that'll be enough to get you through your homework tonight. You have 2 things. Yeah, do you see it? We are a day behind on the agenda. Yeah, so you're doing that inverse foldable that you grabbed when you walked in, little gold paper there. Hopefully. And I think it's a little practice quiz. It's like 1 to 19. Do you see that? Mm-hmm.